All right, so this is going to be what I assume is part 1 out of 2 or 3 of the final exam review. For the fall semester of 2023. So we currently are. Then for posterity, I'll include that at the beginning. So the following announcements are specific to fall semester 2023. If you're listening to this video, watching this video, I guess, at a time that is not that specific semester, note that this information might change. All right, but since we're all here live listening to it right now in fall 2023, stuff you should know for the final. It is on the Monday of finals week. This semester, the final exam is online only, so there is no in-person part to the final exam this semester. It will be open all day Monday. So I think it opens up at like 7 a.m. and then the due date is set for midnight. So take it at any point in time in there. It functions just like a regular exam we've been taking. So the online stuff has all been open note. Final exam will remain open note. It has a time limit of 2 hours instead of 1 hour because there's roughly twice the number of questions. So double the length, double the time limit. The final exam is cumulative, so it'll cover stuff from every single worksheet. You can take it at any point in time on Monday, not specifically the 10 to noon, which is what time the final exam schedule says math classes take their exams at. We're used to taking them at any point in time during the day, so we'll just keep it that way. What else? Final exam relief. If you did not know, by university law or by law, or I don't know, whatever the word is, there is a policy out there that says that if you somehow get scheduled to have 3 final exams in one day, you are entitled to relief from one of those. So someone must reschedule you if you have 3 exams in one day, should you request it. And if you want that, if that happens to be you and you are in this class and you would like to reschedule my exam or our exam, it is our exam, that's totally fine with me. Just send me an email letting me know you want to reschedule this exam. Also, I'm going to cover some stuff from worksheet 15 in this video. So I'll take a brief tangent to go do that when we get to that material. I believe those are all the announcements I wanted for today. Is it in order? Not really. It's kind of going to go all over the place. There'll be some amount of structure to the exam review, but not like a ton. I'd say it's about as in order as any of the other exam reviews are. But with all that said, let's actually get to the problems on this exam review. So here we are. Problem number 1. We want to find the exact value of the tangent of pi over 6. So starting with a quick restatement on what an exact value is. An exact value is, an exact value is not a decimal approximation. So the square root of 3 is an exact answer, but the square root of 3 is an irrational number, meaning that it cannot be represented as a fraction, nor does it have a terminating decimal string. If we tried to express it as a series of decimals, that decimal string would run on forever. So options E and F are decimal approximations, and therefore they are not exact. Even though they are pretty accurate, because they go out to like, I don't know, 8 to 10 decimal places, it is still an approximation. Oh, you can't see my screen. Really? This whole time? Well, that's not great. Okay, well, scrap that first little part of the video. All right, now it should be up. Probably you were stuck on the announcements page for a while there. Whoops. But okay, again, the part that I was saying there, the exact value Options E and F are decimal approximations and not exact. So if we go to our knowledge of the unit circle, we should hopefully remember that the tangent of pi over 6 is √3/3. The way that I tend to remember that is that 6 is 3 plus 3, so it's got 2 3s in its angle. 6 is 3 plus 3. And then the answer is √3/3, so it also contains 2 3s in the answer. So that's how I distinguish between √3/3 and just square root 3, between tangent of pi over 6 and tangent of pi over 3. Just count the number of 3s. Or alternatively, just have that in your memory. Or alternatively, just have the unit circle open while you're taking the final exam. That'll work too, as long as you can get there quickly. All right. The exact value of the sine inverse of -1/2. That's negative pi over 6. So remember the way that the inverse trig functions are defined. We are looking for an angle that has a sine value of -1/2, but 11 pi over 6 does not work. So even though the sine of 11 pi over 6 is -1/2, it is not the solution to the sine inverse of -1/2. Just make sure you end up in the correct set. All right, number 3, for this equation, y equals a tangent function. Find 2 consecutive vertical asymptotes. So I'm going to take my inside, x plus pi over 3, and set that equal to k pi. So this goes back to worksheet number 8. In that set, we know that tangent has its, whoa, I'm forgetting a step. In that worksheet, we know that tangent has all of its asymptotes at the pi over 2 values. So that actually should have been x plus 3 equals pi over 2 plus k pi. So again, it'll have its vertical asymptotes at x equals pi over 2, and then x equals 3 pi over 2. After that, we get another one. Probably x equals 5 pi over 2. All the odd multiples of pi over 2 is where we'll find asymptotes for tangent. So we're going to set the inside equal to that general formula and then solve for x. So if I subtract pi over 3 to the other side, pi over 2 minus pi over 3 is going to be pi over 6 plus k pi. And then if I get a common denominator here, this will be pi plus 6k pi over 6. So then listing out some of our asymptotes here, pi over 6 would be the first one, or at least the first positive one, and then we'll count by 6s. So 7 pi over 6 would be next. After that, I'd get 13 pi over 6. And so on. Let's try to make those dots more in line with each other. So all the multiples of 6 plus 1 pi over 6 will be vertical asymptotes for this thing. So hopefully 2 of those will show up in our multiple choice options. And it looks like option E has 2 of those in order. Pi over 6 and 7 pi over 6. Or specifically, x equals pi over 6 and x equals 7 pi over 6. Since these are asymptotes, they should be equations, specifically equations of vertical lines. Why count by 6? So if you notice, the magenta 6 over in the numerator of my common denominator fraction. The k pi's have a multiple of 6 on there. So I'm plugging in integer values for k. It's like 0, 1, and 2. And that'll mean I end up counting by 6s. So if I plug in 0, I get pi over 6. If I plug in 1 for k, I'll get 7 pi over 6. Plug in 2 for k, I'll get 13 pi over 6. Suppose I could write that part down. K equals 0, 1, 2, and so on. All right. And we're now at the point where we get to go look at polar coordinates. So let's take a brief sojourn over to the notes. And do polar coordinates real quick. So we are definitely familiar with the rectangular coordinate system, also known as the Cartesian coordinate system, which is the 2D coordinate system that uses X and Y to count out the horizontal and vertical scales in a 2D plane. So the X and Y axis are part of the rectangular coordinate system. It's the way that we generally understand two-dimensional space. We think of it as basically as a rectangle. So we can move left to right, or we can move up and down, and X and Y just tells us how far left and right to go, or how far up and down to go. So that's the rectangular coordinate system. Since we now know trigonometry, we could shift to thinking about a polar coordinate system instead of a rectangular one. So in a polar coordinate system, instead of thinking about two-dimensional space as a rectangle, we'll think about coordinate space, two-dimensional space, as a circle instead. So instead of measuring how far left and right a point is, and then how far up and down a point might go, we'll instead measure a distance from the origin. We'll call that sort of like a radius. And then an angle measured from some standard position. So instead of using X and Y coordinate points to locate a point out in space, we'll use a radius and an angle to locate a point. And nice thing about polar coordinates is that we've actually been working with polar coordinates since nearly the beginning of the course. We just need to recognize it now, and then know what to do with that. So the unit circle is our very first introduction to polar coordinates. So the unit circle measures points in some two-dimensional space based on a radius and an angle. The special thing about the unit circle is that we're going to fix the radius to be 1 and then just measure angles around from there. So polar coordinates basically just take the unit circle, but allow us to change the radius to be any value that we want. Instead of sticking to only a radius of 1, we'll have a radius of any value that we want. So that circle that we see over on the left side of the screen is just an example of what a graph would look like in polar coordinates. So instead of looking at an X and a Y axis, we instead look at an origin and a series of concentric circles out from that. Instead of counting maybe hash marks along the X axis, we could count a number of circles out from some center. So if I were to look at, how about the red point? The red point B is at a polar coordinate of 8 and 5 pi over 6. So we're always going to list polar coordinates in order of r theta. R for radius, theta for an angle. Just like for rectangular coordinates, we always list our points x, y. Polar coordinates will always go r theta. So that red point at 8, 5 pi over 6 is telling me that I have a radius of 8 or a distance of 8 out from the center and an angle of 5 pi over 6. So if I want to locate that point out in space, I'll draw in that red line at theta equals 5 pi over 6, and then count out 8 circles from the center. And this particular graph has an outer edge of 8. So I have the first 8 circles drawn into this graph, meaning that 8 is going to be the outermost circle. So that point B out over here, that's where I'm going to find the polar coordinate 8, 5 pi over 6. Past that, there are a couple of videos that cover polar coordinates, so I'm going to leave it here for now. Other than to talk about the conversion system between polar coordinates and rectangular coordinates. So we're already used to x being the cosine value off the unit circle and y being the sine value off of the unit circle. So we're going to keep that for our conversion between polar coordinates and rectangular coordinates. We just need to multiply in the fact that our radius could be something other than 1. So we'll keep x being cosine theta and y being sine theta. But now I'm going to multiply both of those values by r to just scale them out to whatever radius I want. If I'm on the unit circle, r is 1 because the unit circle has a radius of 1. If I'm in polar coordinates, then my r value could be any number. So I'll just multiply it in to find my spot, to find my point. So x will be r times cosine theta, y will be r times sine theta. Bringing things back to the point that we were at, I want to take the rectangular coordinates 3, -3, and convert them back into polar coordinates. I also need the other two conversion equations that I stopped talking about because I didn't pay close enough attention to what problem I was doing. If I want to find theta and r starting from x and y, so if I want to go from rectangular coordinates to polar coordinates, I have a couple of equations that probably look fairly familiar. One of them is tangent of theta is equal to y over x. That's an equation we've already been using. That's the same equation we have on the unit circle. Tangent of theta is the y value divided by the x value. We also frequently see it as sine theta over cosine theta, but on the unit circle, that's y over x. So that equation still holds true. And the other equation is basically just, it is the Pythagorean theorem. We're thinking of r in the coordinate system as a radius, or r in the polar coordinate system as a radius. So r squared is going to be equal to x squared plus y squared. Since r will be the hypotenuse of whatever triangle that x and y will help us complete. So now take things back to the final exam review. So we have rectangular coordinates at 3, -3. And we want to find those polar coordinates. Let me start by making myself a little bit more space. I'm going to shift all of this up a little bit so I can use the space to talk about our polar coordinates. So I'm looking for r squared. I know it's going to be equal to x squared plus y squared, which is going to be 3 squared plus -3 squared. 9 plus 9 is 18. Make sure that the negative gets squared as well. So if r squared is 18, r itself is plus or minus root 18, which we could simplify to be plus or minus 3 square root 2. So unlike a hypotenuse of a reference triangle, an R value in polar coordinates can be positive or negative. So I'm gonna throw a plus or minus on there for just a second, and then figure out where to go. All right, after that, we should figure out what our tangent value or what our theta value is. And our starting bit is just that tangent of theta, which is y over x, is equal to -3/3, which simplifies to -1. So looking at tangent of theta is equal to -1. I maybe don't know what theta is equal to just yet, because I could find several solutions to the equation. Tangent theta equals 1, but I know that it's going to have a reference angle of pi over 4. So one of the pi over 4s is going to be our theta value here. I'll also need to figure out which one I want. So to do that, let's go look at our x and y coordinate point, which has a positive x value and a negative y value. Which has got to show up in quadrant 4. So I'm going to need to find one of these polar coordinate points that shows up in quadrant 4. So if I just go to look at where all of those are, I'm going to ignore A for just a second. Options B through E all have positive R values, so I can just take their angles at face value. That guy's in quadrant 1. 3 pi over 4 is in quadrant 2. 5 pi over 4 is in quadrant 3. And 7 pi over 4 is in quadrant 4. So right there, it looks like option E should be my correct answer. I've got an R value that is correct. One of my two possible options need to be positive or negative for √2. And I have an angle, 7 pi over 4, that puts me in the 4th quadrant. Cool, I'm in good shape. Now, let's talk about option A. Because option A has both a negative radius and a negative angle. But more importantly, it has a negative radius. If I have a negative R value in polar coordinates, that means that once I've picked my angle, I'm actually going to go backwards from that angle instead of forwards along that angle. So if I've got this angle of negative pi over 4, which is in the 4th quadrant, because pi over 4 should point into the 4th quadrant, my negative R value means instead of going forward into the 4th quadrant, I should actually go backward along that angle up into the 2nd quadrant. So even though negative pi over 4 is in the 4th quadrant, this polar coordinate is in the 2nd quadrant because it's got that negative R value. It's going backwards along the angle negative pi over 4. So only one correct answer is listed in these A through E options. Oh, what else do we have going on? More exact value stuff. Finding the exact value of the cosecant of 7 pi over 3. Well, let's see, this thing, if I take 7 pi over 3, which is larger than the unit circle, 7 over 3 is more than 2. So that thing has gone beyond 1 unit circle, so I'll find a coterminal angle. Means I'll subtract 2 pi. So that's 7 pi over 3 minus 6 pi over 3. Leaves me with just 1 pi over 3. So, because pi over 3 and 7 pi over 3 are coterminal, cosecant of 7 pi over 3 should be equal to the cosecant of pi over 3. Which is going to work out to 2 root 3 over 3. If you've looked at any of the cosecant values. If you haven't, or haven't looked at them in a while, the way we get that cosecant of pi over 3 is the reciprocal of the sine of pi over 3, which means I need the reciprocal of root 3 over 2, which is 2 over the square root of 3. And if we rationalize that, 2 square root of 3 divided by 3. So that rationalization step is multiply top and bottom by the square root of 3. So keep in mind that if you have a multiple choice question on an exam, which since this is an online exam, almost all of them are going to be multiple choice questions. The answers that I give you in the multiple choice bank will all be rationalized. So the answer that I would put in the box is that 2 root 3 over 3. So you'll just need to know how to see that answer and know how I got there. Because for the sake of standardizing things, rationalized answers will show up in answer boxes. All right, what else do we have going on? We've got a medical alert helicopter. Is 120 miles south and 15 miles east of a hospital. If the pilot wants to travel directly to the hospital, what bearing should be taken? So I should draw a diagram here. So I'm going to start up at some hospital. If I want to get to the helicopter, I should go 120 miles south and 15 miles east. Well, I didn't quite end up where I wanted it. Close enough. And then I want to label where stuff is. My hospital, denote it with a red cross, is up here. And my helicopter is over here. H. Well, but heli. Hospital and helicopter both start with H, so I'll give it a slightly more put together label. And I want the helicopter wants to travel directly to the hospital. So I need the bearing from the helicopter to the hospital. Meaning if I connect these two dots right here, I'm looking for the helicopter traveling that way. So put some coordinate planes right there, or a compass rose right there. The bearing angle I am interested in is that one. That's the bearing I've got to find. And continuing to label my sides, that length was 120 miles. That length was 15 miles. My triangle's not exactly to scale, but that's okay. So I want to find that angle beta. A couple of ways I could do that. I could complete the other angle that is adjacent to beta, and then say that beta should be 90 degrees minus that angle. Or I could use some geometry to say that this angle in the upper left corner, which is it's an opposite interior angle, Those two angles are equivalent to each other. They're congruent to each other. I believe that's the word that we use back in geometry. So since I know those two angles ought to have the same measure, I could just calculate the beta that's on the inside of the triangle and use that to find my bearing angle, because I know they have to be the same. So looking on the inside of that triangle, I know my opposite side is 15. I know my adjacent side is 120. So I'll say that the tangent of beta must be 15 over 120, opposite over adjacent. So then if I want beta itself, I can get the arctangent of that other side. Try that one more time. So beta is the arctangent, or the tangent inverse of 15 over 120. And when I put that into a calculator, I got 7.15, nope, 13 degrees. I can read my own handwriting. So my bearing angle should be 7.13, 7.13. And if I'm going from the helicopter to the hospital, so the helicopter is the thing that I want to travel to the hospital, it needs to be going northwest. So I want my northwest bearing at an angle of 7.13 degrees. Because there's a bit of a trick question on this one. It's also got, what else is up there? Southeast, 7.13 degrees. But that would be the bearing from the hospital to the helicopter. Now I just want to go the other direction. So I want the one that goes northwest, not southeast. Okay. Next. For an object in simple harmonic motion given by the model d equals -5 sine of 4 pi t, where d is in feet and t is in seconds, the maximum displacement and the frequency of the object are respectively blank and blank. So the values that are important, that -5 is going to be important to us, and that 4 pi will be important to us. The maximum displacement is just going to be the absolute value of A. The absolute value of A is the absolute value of -5, so 5. Our maximum displacement should be 5 rather than -5. Because that maximum displacement is always an absolute value. Remember that the maximum displacement is just a slightly different way of asking for the amplitude. And then we also want the frequency. And generally, to get the frequency, we end up finding the period first, and then we get the frequency from that. So I'll start with finding the period, which is 2 pi over b. So 2 pi divided by 4 pi, which simplifies to 1/2. And then the frequency is just the reciprocal of the period. So 1 over 1/2. That comes out to 2. So our maximum displacement and frequency, respectively, are 5 and 2. Option E. Then another fun exact value problem. Find the exact value of the arc length of a circle with a central angle of 100 degrees and a diameter of 4 feet. So with central angle, that's because I don't remember exactly which way I'll have written the question on the exam. Sometimes we claim it has a central angle. Sometimes we say that an arc is subtended by an angle of whatever, those both mean the same thing. So you see subtended, that's just one of the words we use to talk about the central angle of an arc on a circle. Just a quick vocab part. Feels like it's probably worth reminding ourselves of that during the final exam review. So we're going to want the arc length formula, which is S equals R theta, where it's important in this formula that our angle be measured in radians. This formula doesn't work if theta is in degrees. It's got to be in radians. So I just need to plug in a value for R and a value for theta, both of which I have. So it tells me that my diameter is 4 feet, which means that my radius is 2 feet. My radius is half the diameter. My angle was 100 degrees. But then I need to convert that angle to radians. So I should multiply by my conversion factor of pi over 180. And then if we simplify that, this is 20 over 18, which simplifies to 10 over 9. So 10 pi over 9. Is what that'll all simplify to. Is there recitation this week? Yes, there is. We have one last quiz to get out of the way too. So quiz 8 is in recitation this week. It'll also help prepare you for the final. It focuses specifically on polar coordinates. Sure, we'll talk about that again on Wednesday. Oh, hey, more rectangular form stuff. Or polar form stuff. So I have an equation, R equals 4 over secant theta. That's currently in polar form. I want to convert it to rectangular form. So, getting a polar equation into rectangular form means that, okay, let me back up real quick. If I have an equation in polar form, that means my variables are R and theta. So R and theta are the two variables that show up in polar form. Rectangular form means I've switched my equation back to being only in terms of X and Y, because those are our rectangular variables. R and theta are our parameters. It's usually what we use. R and theta are our polar parameters. X and Y are our rectangular parameters. So if I want to get this thing back into rectangular form, the only two parameters I can have in my equation are X and Y. Meaning A and B and C and D, those are all out, because those all have the R parameter still in the equation. By the time I've completely converted back to rectangular form, R and theta will be absent from the equation. So I need to substitute both of those parameters out and leave it only in terms of X and Y. So here's how I would go about doing that. First off, just write down what those equations are. R squared is X squared plus Y squared. X is R cosine theta. Y is R sine theta. And tangent theta is Y over X. Those are the four that we have. So notice that in all of those equations, we never really have R by itself. So if I'm trying to substitute R out of the equation, I'd rather have it of the form R cosine theta or R sine theta or R squared. So if I ever have an R hanging out all by itself in a polar equation, I'm going to want to multiply with some other factor to both sides before I convert it back, because trying to deal with a plus or minus square root of X squared plus Y squared isn't ideal for trying to change this thing back. So I'll start with something like R equals 4 cosine theta. So notice I started with 4 over secant theta. Secant and cosines are reciprocals of each other, so 4 over secant theta is the same as 4 times cosine theta. That'll be the first step I take. But now, since I have that r floating by itself on the left side, I'm going to multiply both sides of this equation by r. Again, anytime I've got r by itself, probably I'm going to want to multiply both sides by r to get r squared in there. Because once I do that, r squared is equal to 4r cosine theta. Now I have two things that can substitute directly. R cosine theta is x, and r squared is x squared plus y squared. So x squared plus y squared is equal to 4x. And now I have an equation that's only in terms of x and y. So I can figure out what that is. Looks like it is option E is the one that matches up. So maybe from rectangular coordinates, we'd recognize this equation a little bit better as a circle. Since almost any time we've got x squared plus y squared equals something, that's a circle of some variety. Cool. So it's a circle. I think it's got a radius of 2 and a center of -2, 0. But that's an old geometry question. I don't think we'll cover that too much here. And that's actually a good stopping point for part 1. Got us through all of the multiple choice sections. So since I'll be ending class here in just a second, I want to point out one other thing. In the live stream section of the notes, I've got a page labeled 12.4. Just for some stuff that I wasn't going to be able to get to today because I was doing an exam review instead. But if I were doing a regular lecture today, these are the problems I would have covered, and I've already done a bunch of the work out. So in the live notes, I've got several polar coordinate examples that you may want to look over. I can also take any questions on that either on Piazza or probably I can carve out some time on Wednesday to talk about any of those questions if you want to. Right. That's the end of part 1 of hey, some other question in chat. Let's go see what's up. Will today's lecture be recorded? Well, technically it was already recorded. But yes, it's been recorded. I'll post it sometime, maybe in the next hour or two. Just depends on how long it takes to process the video. Yes, the homework grade drops will happen after the exam. So since I reopened all the sets, it'll just be easier to enact all of those drops after I've set the due date. So they're due Monday of finals week at midnight. So sometime after that, I'll be able to go figure out the drops. But yeah, I'll still drop your 2 lowest sets. You're welcome. Hi.
I'm true, so I'm formatting about the intermediate exam.
Oh, yeah. Did we say?
I was today at 4.
Okay, cool. So I probably would have gotten something. Yeah, I gotta get an exam testing center. But okay, so let me first. All right, here's the end of the video. I will see you guys later. Okay, bye.